Alright, so welcome to the next section of our course called Completing the Square. As you'll see later, this technique is very useful for both solving the equations and sketching the graphs. To show you what I mean by a complete square, let's have a look at this quadratic expression. As you can probably see, when I expand the brackets with x plus 4 squared, I will get something with x squared. So therefore this is a quadratic expression. But now it looks slightly different from what we are used to. Ax squared plus bx plus c. That's because ax squared plus bx plus c is a general form of the quadratic expression. But the one on top is called a complete square. What's the difference? In a complete square, we have x inside the squared bracket. And also very important, there's no x outside of that bracket. And the process of the completing square is basically getting from the general form to the complete square form. But to begin with, let's do the opposite. Let's get from the complete square to general form. And to do so, we will first have to expand the bracket x plus 4 squared, and I'm going to use that formula, a plus b squared equals to a squared plus 2ab plus b squared. So I'll get x squared plus 2 times 4 is 8, x plus 4 squared is 16. So that's the bracket. And don't forget we also have this negative 16. So I'll just copy it. And now look at this. Plus 16 and minus 16 will cancel out. And all I'm left with is x squared plus 8x. And now we could say that x squared plus 8x equals to x plus 4 squared minus 16. But in this example, we moved from the right side to the left side, from the complete square form to the general form. But now the question is, how can we possibly move from left side to the right side, from general form to the complete square form? To understand it better, let's have a look at a geometrical interpretation. Okay, to understand the completing square better, let's say we have a rectangle with the sides x and x plus 8. So the area of the rectangle would be x times x plus 8, and that will be x squared plus 8x, same as in our previous example. Now, what I want to do is to rearrange this rectangle and somehow get something similar to a square. So first of all, I'm going to split the long side into x and 8. Now this side is going to be x, and that one is x. Now what is remaining is 8. And now what I want to do is to cut out this rectangle. Again, remember, my goal is to rearrange this and get a square, or at least something similar to a square. For now, I have a square and a rectangle with the side 8 and x. And no matter how I try to rearrange it, I can't get a square. So now what I'm going to do is I will split my rectangle again into 2 halves. Now I have 2 rectangles with side x and 4, which is a half of 8. I can rearrange this to get something similar to a square. Now this looks almost like a square, and the side of that square is going to be x plus 4. And we also have x plus 4 right here. So that means the area of this full square is going to be x plus 4 squared, apart from the fact there's a little square missing. Now, what would be the area of the small square? One side of a square is 4, and the other side is 4. So the missing area is going to be 16. So all in all, my area is going to be x plus 4 squared, then take away the missing area, which is 16. And if you look at this expression, it's going to be exactly the same as the one I got previously. Okay, now let's have a look at what we did with the rectangle. First of all, we started with a rectangle with sides x and x plus 8. Then we cut out the square with the side x. So the remaining part of the side is 8. Our next step was to cut the rectangle in half. That's what we got. A square with the side x and two rectangles with the sides x and 4. And where did 4 come from? This is the half of 8. Now, what did we do next? We took one of the rectangles, let's say this one, and we placed it on the side of the square. And then we took the second rectangle, let's say the orange one, and we placed it at the bottom of the square. So all in all, we almost got a square with the side x plus 4. Apart from this little hole that is missing. Now, what is this missing area? If you still remember, the sides of the rectangle are x and 4. So we have 4 here and 4 there. Now that is a square with the side 4 and 4, so therefore its area is 16. Now let's look at the area of the initial rectangle. The area is x times x plus 8, which is x squared plus 8x. After rearrangements, we got a square with this corner missing out. So the area would be x plus 4 squared, take away the missing area, which is 16. Where did 4 come from? If you look above, you'll realize 4 is a half of 8. Now, where did 16 come from? That's the area of the missing square. And it is 4 squared, so therefore, the number outside of the bracket is always with a negative sign, and we get it by squaring that number. And now it looks like we got a procedure for completing the square. The number inside of the square brackets should be half of the number next to x. Now, the number outside of the squared bracket is always the square of the number inside the squared bracket. Let's have a look at a couple of examples. Let's try to complete the square in this expression. First of all, I need the squared brackets and x inside. Now we know that the number inside the bracket should be half of the number next to x, which is 3. Now don't forget, outside of the bracket, we need to square 3, which is 9, and then we can just copy -4. And now simplify x plus 3 squared, and then -9 minus 4 would be -13. And we're done. Now I think it's time to have some more practice and have a look at the exercise 1 from our question book. I will see you there.